Welcome to the Eduonics Cloud course. Today, we're going to investigate cloud models. This is a document with the title Cloud Models, and you can find this document in the documentation folder for this chapter. This first image we are looking at here will outline what we will discuss in this segment. So we will look at the characteristics of the different cloud models. We will look at the definition of the models by the service they provide, and we will look at how we can classify cloud models by their deployment characteristics. Let's start by providing a definition for the cloud, what the cloud is. Now, cloud is a computing environment. The cloud is a computing model where we have ubiquitous, that is, pervasive, convenient, easily accessed, and on-demand, we can use whenever we like. Network access to a shared pool of configurable computing resources. Now, configurable means we can set them up to be just like what we want, and these sorts of computing resources are not limited to, but include networks, servers, storage, applications, and other services like email, for instance. The attributes that we are defining to the cloud as being important for any cloud that satisfies our definition are that it provide an on-demand self-service that is elastic, that it has broad network access, it have resource pooling, and it be a measured service. That is, we can work out how much it's costing us now and how much it will cost us in the future and what sort of benefit it brings to our customers. Let's start by unpacking some of these terms. So let's look at the expression resource elasticity. We can expand that and understand resource pooling at the same time. Resource pooling and an elastic or elasticity in our service. So let's start by defining what is a resource. Well, just as when we have real physical in-house architecture, such as an in-house server, it will have a CPU, it will have some memory, and it will have a storage device with a capacity. We can think of those three things, CPUs, memory, and storage devices, as resources. If we had three physical servers and all of a sudden the demand on one of the servers increased, could we take resources from the other two servers and assign them to the one server that is experiencing the peak demand? Well, physically we can do that, but it is difficult. This is one of the things about the cloud, is that we can easily move these sorts of resources between servers in the cloud to meet periods of high demand. And this is basically what a resource and resource elasticity is talking about when we use those terms. And this can be made a little bit clearer with this diagram here, which we will go into now. Consider we have a business on the internet and we offer a service. Then there will be a demand for our service and we must provide resources to meet that service. We will consider our total resources to be our capacity and we plan for a certain demand or we budget for a certain demand. Now, a safe practice and a good practice is always to be able to have a planned capacity that meets our maximum demand. But this, while good budgeting, is not always practical or achievable because we cannot know in advance what the demand will be, and unwise, in a commercial sense, is to allow our demand to exceed our capacity. In this case, our service will become unstable or unavailable for certain users during our time of maximum demand. And on the internet, when people access your resource, if it's not available, you run the risk of losing that customer. And so it's very unsafe or unwise from the commercial perspective. Here we have a situation that we can consider wasteful. Resources are expensive. Here, our planned capacity far exceeds our maximum demand. This is a wasteful or poor budgeting situation, though quite common because we cannot effectively predict what will happen in the future. So we cannot effectively plan for our capacity in most commercial situations. Here we have the best of both worlds. Here we have what's called the elastic capacity. Here the capacity is mirroring the demand. As the demand increases, so does the capacity. As the demand decreases, then the capacity decreases as well. This is the best utilization of resources and the best commercial outcome. And this is one of the great achievements of what the cloud can offer a business on the internet. Now we will look at this elastic capacity and how it is offered by the different commercial providers in the cloud services that they offer as we progress through this course. To summarize, we have defined what a cloud is, how we can use it, what is the idea of a cloud resource, and, in particular, an elastic cloud resource. We have mentioned this idea of analytics, of understanding what the costs will be and what are the services that are provided per unit cost. And then, of course, there's this whole idea of infrastructure management. How can we have an elastic infrastructure so that we can pool resources to meet a demand in an area where the demand is increasing and move resources from an area where demand is decreasing? An elastic resource, infrastructure management that we can quantify and use to model and budget. So now, we'll look at defining, in more depth, the particular service models. How we can have models for cloud services, models for the types of clouds. Whether we have an on-premises cloud, which we could think of as being a private cloud, and then we can have an off-premises cloud, which we can think of as being a public cloud. And then we can have a combination of both, which is the hybrid cloud. There are many services offered by the cloud, and there is a well-established, commonly used schema to categorize cloud services. And this schema provides a series of layers, and together they make what can be referred to as the cloud computing stack. So we have, at the bottom layer, IaaS, or Infrastructure as a Service. Then the next layer, PaaS, or PaaS, known as Platform as a Service. And then a top layer, SaaS, SaaS, or Software as a Service. So these provide a schema to break down cloud services. Infrastructure as a Service is for hardware or virtualized hardware. Platform as a Service is a layer that you can use to create applications. And then Software as a Service is software that is provided by the cloud. So we can look at examples for these layers. For Infrastructure as a Service, we have the Amazon AWS, or Amazon Web Service, EC2, or Elastic Compute. So Amazon EC2 is an infrastructure service. Then we have the new Google Cloud Platform. Also, a well-known cloud provider, Rackspace. These three companies are leaders in the IaaS, Infrastructure as a Service, layer of our cloud computing stack, or schema. And we will look at the services in particular at this level in the schema from Amazon and Google Cloud Platform later in the course. Then for PaaS, or Platform as a Service, we have the well-known Google App Engine, Windows Azure, the Rackspace site, and then we have the Red Hat. Red Hat opened a service called Red Hat OpenShift. Software as a Service layer. We have the very well-known industry leader Salesforce. We also have Google Docs and another not quite so well-known but extremely innovative Google Fusion Tables. So these are the examples of company offerings or services that correspond to the actual schema layer. So for the infrastructure layer, we have the ability to create virtual machines on Amazon, Google, or Rackspace. At the platform as a service layer, we can create applications inside services known as Google App Engine, Windows Azure, or Red Hat services. And for software as a service, for examples, we can have Google Docs. There are many more examples and more companies coming online and offering cloud services all the time. But these are representative of the well-known samples for each layer in our schema or cloud computing stack. This is a graphical way to illustrate how we will interact with a schema or service layer. You can see for blue, we manage it ourselves. For yellow, it's managed for us. And you can see with traditional IT before the cloud, we did everything to do with providing an internet or establishing internet services. And for infrastructure as a service, we must provide only the operating system, the middleware. This can be things like a server, like Apache server, or it could be JBoss middleware tools. Some middleware, then a runtime. By a runtime, we mean a language runtime. It could be Java or Python or some other language. The data layer, this could be a database. And then the application which calls on all these resources that we must provide. And the cloud provider provides a virtualization platform that runs our virtual machine stack outlined in blue. For platform as a service, we just provide the application layer and the data layer. The actual runtime and the middleware, the operating system, the virtualization, and the hardware are all provided for us. With software as a service, everything is provided and we just use the software online. Now, you might think that this is the end of the traditional IT approach, and nothing could be further from the truth. If you are involved in development of software and you have been involved for the last 20 years, you will see a cycle. Back at the beginning of the internet, there was a cloud in place then, and that cloud was the ARPANET, the precursor of the internet. The ARPANET, Advanced Research Project Agency Network, was not just the precursor to the internet. It functioned for government workers, scientists, and academics as a prototype cloud where information, ideas, and computing resources could be shared in a way that allowed pooling of services, very much the way the cloud works today. The ARPANET evolved into the internet, and the internet has evolved into the cloud. But we will see a change that will swing back to the more traditional IT, and this change will be driven by two factors, one technological and one social. The technological factor will be the decreasing cost of the hardware to run cloud-type services. This hardware, while reducing the cost, will increase exponentially in computing power. And on the second factor is the increasing miniaturization that this hardware will take. Increasingly, we will find much more powerful hardware fitting into much smaller spaces. The second change is a social change, and that is the value of information. Increasingly, a company's chief and most valuable asset will be its information from its research or other related activities. And so the security of that information will be the key factor. Increasingly, we will find online data which will increasingly become a factor in the cloud. As hackers will increase the resources and the skill base available to them, the cloud will become increasingly less secure in the informational sense. The decrease in the cost of the computing power and the increase in the security issues, the increase in the value of the information, and the decrease in the security of that information online, all of these factors will serve to push back data into the traditional IT model. Finally, we will wind up this segment by looking at deployment models. These are models for clouds based on deployment. Now we have a schema of public, private, and hybrid. Where hybrid is a mixture, public clouds are growing in popularity and increasingly become the dominant model. Where hybrid is a mixture, public clouds are growing in popularity and increasingly becoming the dominant model. This is because they provide user-driven solutions to real problems, analogous to the open source in development. By having a larger user base, users helping other users, this lowers the barrier to participation. Private clouds exist because they help leverage existing capital expenditure in information technology. Clearly, by networking databases and servers, advantages are obtained. At the other end of the spectrum, we have the public cloud. Here we are shifting from capital expenditure to operational expenditure. By offering the pay-as-you-go billing model, the capital expenditure to create the public cloud can easily be defrayed. The expense becomes the operational expenditure for things like security and maintenance. Between the two ends of the schema, private and public, we find between the hybrid cloud. The company Amazon provides a good use case for the evolution of the hybrid cloud. Amazon had great commercial success with its website, Amazon.com. In creating the website, Amazon.com, Amazon had to make a large capital expenditure to create a server farm that backed up that website. Amazon was able to leverage the capital expenditure in creating the server farm that backed up Amazon.com as a public cloud, Amazon Web Services. So, there we saw the classic development of the hybrid cloud. We had the original Amazon.com commercial website, the large capital expenditure to create the information technology resources that provide the services provided by Amazon.com. And then the leveraging of part of that information technology resource as a public cloud. Amazon maintains the Amazon.com website on a private cloud, then outsources into a public cloud, Amazon Web Services, and used existing information technology resources to create the hybrid cloud, Amazon Web Services. We will wind up this discussion of cloud models by introducing this concept of virtualization. Virtualization is the way you can create a software analogy of a real physical machine. So we can have a physical server with its CPU, hard disk, and motherboard, but we can create a virtual server which is a software version of that physical equipment. Now this is what's made the cloud possible. By creating virtual boxes or virtual servers, we can reduce the need for space and power. OVF is an open standard for packaging and distributing virtual appliances, or more generally, software to be run in virtual machines. The standards for this are still a work in progress. However, there does exist at this time popular virtual formats. Amazon, as a leader, has developed its own virtualization technology or format known as the Amazon Machine Image, or AMI. VMware, the industry leader, has its own format known as VMDK, or Virtual Machine Disk. Red Hat Linux and its brother Fedora have a virtualization technology known as KVM. Virtualization is possible because of this innovation known as a hypervisor, which we will introduce in the next topic. The company Zen is a leader in hypervisor technology, and they have their own format known as IMG. We'll move on now to look at the existing cloud architecture and the new emerging cloud architectures in the next topic.